Good day everyone. I am Johnny May Mahumot and I am reporting about trigonometry. My assigned topics are geometric trigonometry and right triangle trigonometry. So those topics have subtopics including triangles, 6 trigonometric ratios, special right triangles, angles of elevation and angles of depression, the use of trigonometric ratios in solving real-life problems involving right triangles. So before that, this is the introduction about or background about trigonometry and geometric trigonometry. The heart of trigonometry lies in geometry. One of the most basic figures studied in geometry is triangle. So, trigonometry is a branch of mathematics dealing with properties of triangles and their applications. They relate the angles of a triangle to the length of its sides. Can trigonometry be used in everyday life? In construction, we need trigonometry to calculate the following: measuring fields, lots, and areas, making walls parallel and perpendicular, installing ceramic tiles, roof inclination, the height of the building, the width, length, and etc., and the many other such things where it becomes necessary to use trigonometry. Architects use trigonometry to calculate structural load, roof slopes, ground surfaces, and many other aspects including sun shading and light angles. Right triangle trigonometry is used for measuring distances that could not actually be measured. For example, the Earth, Moon, and Sun create a right triangle during the first quarter moon. The distance from the Earth to the Moon is about 242,002.5 miles. What is the distance between the Sun and the Moon? So, in that question, we can answer that through using the trigonometric or using the 6 trigonometric ratios. Okay, for the subtopics, we have include triangle. So, trigonometry is all about triangles, the measures of triangle. So, I will discuss to you some basic information about triangle. So it is a polygon formed by the three segments joined at their endpoints. So this is a line segment, three line segments. The segments are the sides and the endpoints are the vertices. The angles formed by any two consecutive sides are the angles of a triangle. So in this triangle, we can make this angle. Mahino siya ang angle. A triangle has three sides, three vertices, and three angles. So in a right triangle, because we are dealing with right triangle in trigonometry, so that we can use the 6 trigonometric ratios in solving those right triangle. So in a right triangle, the sides that form the right angle are called the legs. So these sides na naka-form siya of right triangle, these are the legs. And then the side opposite the right angle, so this is the right angle opposite niya, that is called the hypotenuse. In a right triangle, we can actually illustrate the 6 trigonometric ratios. So consider the right triangle ABC. So this is our A, B, and C. In this triangle, we let theta represent the angle. So this is our theta, angle theta. Then the leg denoted by A is the side adjacent to theta. And the leg denoted B is the side opposite to theta. So through this, we can illustrate the 6 trigonometric ratios. We will use the convention that angles are symbolized by capital letters. So this is angle A, angle B, and angle C. While the side opposite each angle will carry the same letter symbol in lower case. So ang opposite ni angle C could be the small letter C, that is the hypotenuse. And then opposite to angle B, small letter B, that is the opposite. And opposite to angle A, that is the small letter angle A, that is the adjacent. So the following are the 6 trigonometric ratios. So first is sine of theta. So sine of theta, that is equal to opposite over the hypotenuse. So we have here B over C. Next is cosine of theta. We have adjacent over hypotenuse. Next is tangent of theta. We have opposite over adjacent. So next is cosecant of theta. We have opposite over hypotenuse over opposite, that is C over B. Then secant of theta is hypotenuse over adjacent, and cotangent of theta is adjacent over opposite. Notice that the three ratios at the right, such as cosecant, secant, and cotangent, are reciprocals of the ratios on the left. So kani siya, reciprocal ni siya. So ang reciprocal sa sine is cosecant, reciprocal sa cosine is secant, and reciprocal of tangent is cotangent. So what have you observed? Kani siya nga mga equation is gibaylo ra. Opposite over hypotenuse. Pag abot niya sa cosecant is na hypotenuse over opposite. Same sa cosine and tangent. So that is our 6 trigonometric ratios. Example, derive the following trigonometric ratios based on the figure. So first, we have sine B with respect to B. This is our sine B. So nganong na 12 over 13? Because our sine is equal to opposite over hypotenuse. So opposite of B is 12. And then ang iyang hypotenuse is 13. So that is 12 over 13. Next is cosine of A with respect to A. Then cosine. Cosine nato is adjacent over hypotenuse. So, asa may adjacent sa angle A diha? That is 12. Dara iyang ka-adjacent. And then, ang iyang hypotenuse is 13. That is 12 over 13. Next is tangent of B. What is tangent dire? Opposite over adjacent. So, tangent of B with respect to angle B. So, asa ang ka-opposite ni B? That is 12. Ang iyang ka-adjacent is 5. So that is 12 divide 5 or 2.4. Next is cosecant of A. That is reciprocal ni siya sa sine. So that would be hypotenuse over opposite. So with respect to A, our hypotenuse is 13 and ang iyang ka-opposite is 5. That is 13 divide 5 or 2.6. Number 5, secant of B. That is kani siya is reciprocal ni cosine, and that is hypotenuse over adjacent. So with respect to B, ang atong hypotenuse is 13, ang iyang ka-adjacent is 5. So 13 over 5 or 2.6. Next is cotangent. Reciprocal ani ni si tangent, and that is adjacent over opposite. So, ang ka-adjacent ni A is 12. Ang iyang ka-opposite is 5. So, 12 divide 5 or 2.4. Next. So, to easily remember the 6 trigonometric ratios, you can use the SOHCAHTOA. This is a mnemonic used for remembering the equation of the 6 trigonometric ratios. So, what do you mean by SOHCAHTOA? So, that stands for sine. So, kung magkahinumdum ta ni sine, atong timan-an nga si sine is equal to opposite over hypotenuse. That is the SO. Next is cosine. That is adjacent over hypotenuse. And TOA, that stands for tangent, opposite over adjacent. So, always remember the SOHCAHTOA. That is very useful in solving or in dealing with trigonometry. Example, we have to determine the equation or formula to find a missing part of a triangle. Because we are dealing with triangle, and we should always remember that we have to find all the missing parts of a right triangle. So example here, figure 1. Given, this is a triangle OYU, right angled at Y. Then given angle O is equal to 53 degrees, then our Y is 12. So unknown is side U and side O. So we have to solve for U. Atong pangitaon ang measure ni U. Solution. Use ka. Why we will use ka? Because ka is equal to adjacent over hypotenuse. So naa naman tayo hypotenuse nga 12. So ang adjacent ni aning angle is unknown. So kato itong gamiton nga formula. So we will use with respect to this given angle nga 53 degrees. So cosine of 53 degrees is equal to adjacent over hypotenuse. Cosine of 53 degrees is equal to U over Y. And Y is equal to 12. After that, we have to cross multiply. So mahimo siyang U is equal to 12 cosine of 53. So you have to input that in your scientific calculator. That is 12 cosine of 53. So the approximate value of U is 7 point something. So mo na ang measure ni side U. Next figure. For figure 2, we have here a triangle BAC, right angled at C. Then given si angle B, that is 67 degrees. And then our B is 10.6. So we have to solve for A, side A. So we will use, mangita taong equation nga atong magamit ni silang mga given diha. Unya, maapil na to si unknown. So we will use the tan or the TOA. TOA is equal to opposite over adjacent. With respect to angle 67 degrees, ang iyang opposite is 10.6. Ang aniyang adjacent is unknown nga mo itong gipangita. So that is tan 67 degrees is equal to B over A. And then substitute na to, si B is 10.6. So we have to cross multiply. Ano siya? That is A tan 67 is equal to 10.6. So A is equal to 10.6 over tangent 67. So if atong pangitaon ang approximate value ni ang side A, mo ni ang result sa calculator. 10.6 divide tan 67. So, ang value is 4.4 or 4.5 something. So, mo na siya ang value ni side A. Okay, next is solving a right triangle means finding the measure of the remaining parts. So, involve gihapon si right triangle ani. Example, triangle BCA is a right angled at C. This is a 90 degrees. If C is equal to 23 and B is equal to 17, find angle A. Kana siya ang unknown, angle B, and A. So, we have to find all the missing parts in this triangle. So, side B is the adjacent to angle A, right? So, this is adjacent. C is the hypotenuse of right angled BCA. So, we will use ka or sine, that is cos. So, with respect to, ang atong gipangitaan is angle A man. So, atong ipangitaon ni angle A ang iyahang ka is equal to adjacent over hypotenuse. So, atong gamiton ang mga mga known nga parts, mga given. So, we will have to use the ka. Cosine is equal to adjacent over hypotenuse. Cos A, so that is our angle A, is equal to B over C. Kaya adjacent kay B man. Si hypotenuse kay C. Then, substitute the value for B, that is 17. Substitute the value of C, that is 23. So, cos A is equal to 17 divided 23 is 0.7391. So, angle man atong ipangita, in our calculator, we have to input cosine raised to negative 1 to get the value for angle. So, cosine raised to negative 1 times 0.7391. So, the result is 42.34 degrees. So, that is the measure of our angle A. So, no na. We already know the measure of angle A. Next is angle B. Since in part A, it was already found that measure of angle A is 42.34, then measure of angle B is equal to 90 degrees minus 42.34, because in a right triangle, the sum of the three angles should be equal to 180 degrees. So, given na diha si 90 degrees plus kani siya nga 42.34, so mangita tag measure sa angle B nga mo result silang tulo ug i-add silang tulo mo result og 180 degrees. So, mo to atong gi-minus si angle B 90 degrees minus 42.34. So, the result is, our angle B is 47.66. So, nakuha na nato si angle A and angle B. The remaining is side A. So, we already know the value for C and B. So, we will use the Pythagorean theorem. Pythagorean theorem is also used in finding missing parts of a right triangle. So, ma-apply siya nato din sa atong right triangle. So, this is A squared plus B squared equals C squared. This is the formula of Pythagorean theorem. So, given diha si B squared ug C squared man sa ato ang figure, so atong i-substitute. Our B is 17 and our C is 23. So, A squared plus 17 squared is equal to 289 and 23 squared is equal to 529. So, next is atong i-move ang like term. A squared is equal to 529 minus 289. So, i-move nato si positive, mahimo siyang negative sa pikas. A squared is equal to 240. So, ato siyang extract the square root. A is equal to square root of 240. A is equal to 15.49. So, the measure of our A is 15.49. So we already know, or we already got the missing parts, the measure of the missing parts of the triangle. Next is, to solve a right triangle is to find the length of its three sides and the measure of its three angles. If one angle is 90 degrees, the sum of the unknown angles is 90. So, example, 90 na diha. So, ang remaining pod nga angle niya should equal to 90 degrees. Example, solve the missing parts of the given right triangle where C is 39 centimeters and angle A is 40 degrees. So, we have to find B. Oh, this is very easy. So, our C is 90. Then, ang B na to is, nanamtay 40 diri ni A, i-minus si 90, atong minusan og 40, kaya dapat 90 na sila. Ang total nilang duha. So, subtract 90 to 40, that is equal to 50 degrees. So, therefore, our measure of angle B is 50 degrees. So, okay na ito ang mga angles. Solving for side A. So, we will use so. Why? Because we already know the measure of hypotenuse. Then ang ato ang with respect ni sa angle nga given. So if we will use u, so this is our opposite. Then this is our hypotenuse. So makuha si A kung pilay measure. Sin A is equal to A over C. So sin 40 degrees with respect to the given angle equals to A over 39 centimeters. So we have cross multiply. A is equal to 39 sine 40. A is equal to 39 times sine 40 is equal to 0.6428. Sine 40. Okay, nara. 6428. So, find B. Sa measure of side B, we will use cosine. Cosine of A is equal to B over C. So, our cos A, our A is 40 degrees, and then our C is 39. So, cross multiply B equals 39 times cosine 40. Cosine 40 is equal to 0.7660. Times 39, our B is 29.87 centimeters. That is the measure of our side B. Next is, in geometry, the following sides of special right triangles are related as follows. So we have the 45-45-90 right triangle theorem and the 30-60-90 right triangle theorem. So, in this theorem, the legs are congruent kay equal man sila og sides nga 45-45, equal man sila og angle. The length of the hypotenuse is square root of 2 times the length of the leg. So that is square root of 2 times leg. In 30-60-90 right triangle theorem, the length of the hypotenuse is twice the length of the shorter leg. And then the length of the longer leg is square root of 3 times the length of the shorter leg. Angles of elevation and angles of depression. So these are the terms involving in angles of elevation, angles of depression. Line of sight, it is an imaginary line that connects the eye of an observer to the object being observed. Angle of elevation is the angle from the horizontal to the line of sight of the observer to the object above. And then the angle of depression is the angle from horizontal to the line of sight of the observer to the object below. Analyze the figures below and answer the questions that follow. In each of the following illustration, identify whether angle A is an angle of elevation or angle of depression. So in number 1, angle A is angle of depression. This is the eyes of the observer to the object below. Then same as number 2, angle of depression. Number 3 and 5 is angle of elevation. This is the eye of the observer to the object above. Then angle number 4 and number 6, that is angle of depression, the eyes of the observer to the object below. The study of trigonometric ratios originated from geometric problems involving triangles. Solving a triangle means finding the length of the sides and measures of the angles of a triangle. Thus, trigonometric ratios may be used to solve problems involving angle of elevation. A trigonometric ratio often helps us set up an equation which can be solved for the missing measurement. If 2 legs of the triangle are part of the problem, then it is a tangent ratio. If the hypotenuse is part of the problem, then it is either a sine or cosine ratio. So example, a tower is 15.24 meters high. At a certain distance away from the tower, an observer determines that the angle of elevation to the top of it is 41 degrees. So nara to ang angle dire. How far is the observer from the base of the tower? So observer then to the base sa tower. So this is we have to find the measure of this side. So we will use the tangent. That is equal to opposite over adjacent. So tan with respect to 41 degrees, tan is equal to 15.4. This is our opposite and our adjacent is x. We let this side our x. So we have x tangent of 41 degrees is equal to 15.24. So, x is equal to 15.24 divide tangent of 41 degrees. So, our x is equal to 17.53 meters. That is the distance of the observer from the base of the tower. Next is this, a trigonometric ratio often helps us set up an equation which can be solved for the missing measurement. If two legs of the triangle are part of the problem, then it is a tangent ratio. If the hypotenuse is part of a problem, then it is either a sine or a cosine ratio. Example of angle of elevation. From an airplane at an altitude of 1,200 meters, the angle of depression to the rock on the ground measures 28 degrees. Find the horizontal distance from the plane to the rock. So this is our x. So we have A is equal to 90 minus 28 degrees. So our A is 62. Kaya nga naman, dapat ni sila mo result og 90 because they are linear pair. Linear. So 90 minus 28, 62 ato ang A. To find x, so we will use the tangent that is opposite over adjacent. So tan 62 with respect to our A, 62 degrees, is equal to opposite over adjacent. Tangent of 62 degrees is equal to x over 1,200. So tan 62 times 1,200 is equal to x. So x is equal to 2,256.87 meters. So therefore, the horizontal distance from the plane to the rock is 2,256.87 meters.
I'm going to find the height of a flagpole I found on my drive. First, I'll find the distance I'm standing from the base of the flagpole. Next, I'll calculate the angle of elevation from where I'm standing looking to the top of the flagpole. For our angle, we have the adjacent side, and we're looking for the opposite side, which represents the height of the flagpole. The trigonometric function we'll use is tangent, since it represents the ratio of the opposite side to the adjacent side. So, tangent of 52 degrees is equal to x, our opposite side, or height of our flagpole, over 35.5. Multiplying both sides by 35.5 to get x by itself, we have x equals the tangent of 52 degrees times 35.5. Using a scientific calculator, we perform the calculation and find that the height of the flagpole is approximately 45 feet.